My research focuses on laser-based technologies, where the interaction between a laser beam and a feedstock material, metal powder or wire, is the most important factor influencing stability of the process as well as the quality of build material. That is why I use various types of sensors to detect any changes of the deposition process. For example, a spectrometer measuring radiation over a melt pool allows to detect approaching process instabilities. Vision cameras focused on the material laser interaction zone allow online monitoring, as well as after additional image processing, the data gives good indications of process deviations. Using less common solutions like measuring current flowing through a feedstock wire gives a direct feedback on the stability of the laser wire process. Finally, combining a few sensors into one automated control solution is a way to improve process stability as well as the quality of built material, and in the end bring the metal-directed energy deposition process one step closer to the goal of a user-friendly turnkey solution.